Welcome to the engine of Enigmas. Constraint satisfaction problems, or CSPs, rely on three components: variables, which represent the unknowns to be decided; domains, the universe of possible values; and constraints, the physical laws of the puzzle. AI solves these using constraint propagation and backtracking. This is the merchant's ledger, a classic cryptarithmetic puzzle. Each letter must map to a unique digit from 0 to 9. The logic pivot starts with the maximum sum of two single digits plus a carryover, which leads to the breakthrough that m must equal 1. The alchemist's formula shows the power of parity and cascading constraints. The parity constraint reveals that g plus g must result in an even number e. The cascading constraint in the tens column helps derive the value of g, which then leads to the final solution. The Chronomancer's Vault features a puzzle with a large state space of over 3.6 million possible combinations. The logic pivot in the units column dictates that 2n must end in 0. This constraint allows AI to instantly prune millions of false paths. The architect's grid, or Sudoku, has a state space size of 9 to the power of 81. The constraint intersection requires a candidate digit to survive a triple filter across the row, column, and 3x3 block. AI solvers use forward checking as an algorithmic defense. The ascetic's trial, or the Tower of Hanoi, is a problem of recursive horizons. The puzzle requires moving n rings from a source to a target pillar, with the rule that a larger ring may never rest on a smaller one. A 64-disc puzzle requires over 18 quintillion moves. The Ferryman's Dilemma is a classic river crossing puzzle. The safety invariant requires that an actor cannot be in the presence of a foreign agent unless their own agent is present. This requires abductive inference, where a single unsafe crossing invalidates the entire trajectory. The Crimson and Sapphire Knights puzzle involves reversible interactions in a one-dimensional state machine. The goal is to swap all red and blue positions. The logic pivot is avoiding deadlocks, which means two pieces of the same color can never end up immediately adjacent to an empty space. The Oracle's Truth involves Boolean satisfiability, SAT. The challenge lies in a dense web of dependencies, where an assignment might satisfy one clause but contradict a distant, connected clause. AI solves this ultimate nitrogen monophosphide complete problem using conflict-driven clause learning. The Cartographer's Palette is a map coloring puzzle with edge constraints. No two connected territories can share the same color. The four-color theorem proves that any contiguous map can be colored with just 4 colors, without adjacent matches. The apothecary's measure is about measuring exactly 4 gallons using a 3-gallon and a 5-gallon jug. Success requires maintaining numeric invariance. State transitions are deterministic, forming a predictable directed graph of state. The Void Navigator's cipher, or Rubik's Cube, has a state space size of 43 quintillion configurations. The state space is non-commutative, and despite its vastness, any scrambled cube can be solved in 20 moves or fewer, known as God's number. The Codex of Complexity summarizes the relationship between puzzle types, primary constraint types, state space size, and the corresponding AI solution pathways, illustrating different approaches to problem solving. Whether etched in parchment or processed by neural networks, puzzles are the ultimate crucible for logic. They prove that complexity is not chaos. It is a set of constraints waiting for the right algorithm. The logic remains yours.